All right, today we're talking about open sentences. When you think sentences, you're probably thinking, oh man, this is English. No, it's math. But remember, math and English relate. They relate, and the reason they relate is because language comes from God, math comes from God. They have to be tied together. They're not just like this, that's that, and that's this. No, they're actually very tied together. Sentences, though, when we're referring to them in math, we're talking about, in our case, equations and inequalities, okay? Equations and inequalities. How many of you know what an equation is? What does an equation have to have? Very straightforward. Eli?
A math problem with an equal sign.
Equal sign. It has to have an equal sign. What does an inequality have to have? Yeah, you could say not the equal sign because they're the greater than, less than, or the not equal to signs. So just, you can think of it greater than, less than. We're going to deal with both of them. We're going to first deal with the equation, then we'll get into the inequality. All right, open sentences. Let's go ahead and get a definition here. What is an open sentence in math? Yeah, we're going to talk about that. It is a mathematical statement and we're going to call those statements equations and inequalities. Sorry about that. That contain one or more variables. Okay, so any mathematical statement, and we're going to define statements as equations or inequalities, that contain one or more variables. That's an open sentence. For the most part, open sentences are neither true nor false until you replace the variable or variables with values. You're like, okay, what did you just say? Let's look at that. Contain one or, yes, I apologize, one or more variables. Thankfully, you guys are bright enough to figure that out. Okay, this is what we're going to do. If you're looking at the top of page 33, do you guys see that purple chart at the very top of page 33? Okay, what we're going to do is we're going to replicate that. So what I want you to do is underneath that definition, go ahead and draw a rectangular box. You're going to divide it in 3 columns. The first column is really not that big. The last column is not that big. The middle column should be the biggest because that's where most of the work is done. And it's not too bad, but does this remind anyone of something we've done in the past before? Yes, sir? Do you remember? Yeah. Do you guys remember the tables that you had to do before you graph lines? This is similar to what you're doing, but you're not going to graph a line yet. Not today.
Not today.
Okay. You're going to have the inequality or equation up here. In this case, 6b plus 7 equals 37. Okay. This is an open sentence. Okay? Why is it an open sentence? Look at the definition of open sentence and tell me yes or no. That is an open sentence. Why or why not? Yep, Ellie? It is.
Because it has a variable.
Okay. Okay, I have a variable, and then one other part it has to have. Yep.
Is it that it's an equation?
Yep, it's also an equation. It's an equation with one or more variables. In this case, it's one. Okay, open sentence. Is this true or false?
Neither.
Neither. It's neither true nor false until I find out what B is. Okay, so we don't know if it's true or false yet. We're going to say here are the B values, and then here we're going to answer true or false. So T or F. So when you put in B, is it going to make that statement true or false? We're going to find that out. Okay, the first number I'm going to replace b with is 3. So you just write a 3 here. And then I'm going to replace b with 3. So I put that in there. And then I evaluate, and then I'm able to answer true or false. So when I put a 3 in here, is this a true or false equation?
False.
False, okay? If you're like, wait, how do you know if it's true or false? What's 6 times 3? 18 plus 7? 25 is not equal to 37. So we put an F, that's false. Okay, this replacement value, notice I'm using the word replacement. This replacement value of 3, is it a part of the solution? Or is it a number that makes the statement true? No. So this replacement value is not a solution. Replacement, solution, those two words are key. All right, let's try 4. 6 times 4 plus 7 equals 37. What do you guys think, true or false? Yeah, 24 plus 7 is 31, and 31 is not 37. That is also false. So the replacement 4 is not a...
True solution.
Okay, good. True solution. Good. Or solution. Good. 5. 6 times 5 plus 7 equals 37. True or false? True. The replacement value 5 is a
True equation.
solution. 5 is a solution. Yep.
So where do you typically start for the bees?
In this case, they're giving you the B's. But when you have like linear graphs, like what we did on our own, remember I gave you a positive number, a negative number, and 0, and nothing too big. I mean, you could make it big and it works, but then your graphs are going to be way out there. And let's try 6. 6 times 6 plus 7 equals 37. True or false? False. Okay, everyone okay with what we did up here? Like you understand what we did? Like this is like, okay, get this. Yeah, go ahead. I'm going to scroll down a bit.
You did one more, like, could more than one answer be true?
Yes, good question. Yeah, that's a good one. So the question was, can more than one replacement value be a solution? And the answer is yes. Sometimes only one is a solution, sometimes 2, sometimes 3, sometimes all of them. But you have to test them out. Now, basically on your homework, you know what you're doing for the first part is they're going to do this. They're going to give you an equation or an equality, and they're going to say, is 3 a solution of this equation or inequality? You evaluate and you say true or false, or does it make it true or false, whatever. And it's just that answer right there on the right. And then later you're going to get these, but you don't have to make a table. I do that so we can organize our thoughts. So whatever it takes for you to organize it. All right, I have some key phrases or key terms here. Replacement set. That's terrible. Replacement set. Okay, I use braces to show replacement sets, but I thought I used braces for order of operations. Yep, I do. The replacement set in this problem was 3, 4, 5, and 6. What does that mean? I tried out 3, 4, 5, and 6. Those were the possible values that I wanted to check out. Does that make sense? They gave them to me, by the way. I didn't have to come up with it. All right. Does anyone know what the solution set was? Go ahead.
3.
3.
No, sorry.
Oh, yes, you're right.
5.
That's okay. You must like 3. Okay. So 5. There's only one of them. Do you guys see how sets are shown with braces? Sometimes you have a lot of numbers. Sometimes you have one number. It's possible to have no numbers as well. Yes, ma'am?
So do you write that under?
Yeah, write this for now.
We did last year, so write under as well.
Oh, no, you're not going to have to do a chart. But when they use the word replacement set, you know what numbers they're talking about. When they use solution set, you know what numbers they're talking about, and you know how to write them. Like, you got to know how to write them.
Can you do a brace for me?
Yeah, so here,
I don't know.
okay, for the brace, I usually start from the bottom. I make a little divot, and then I do like a V, or a little point, and then I do that. Just go slow. Like, yeah, like, you kind of know how it looks like. When I make the worst braces is when I'm going the fastest. Like, when I just like, I did one brace, I went like this. That's a brace. That's not a brace. So I go slower and I can get a brace going here. Does that make sense? Go slowly. Make good braces.
Oh, you kind of go in. Oh.
Yeah, you kind of do this little curve,
Okay.
then a little spike, and then another curve.
Mine looks like a cat.
Okay. All right. Any questions on how to write your sets with braces? Are you guys good on that? Do you guys know the difference between a replacement set and a solution set? See me after class. Okay, so we have the difference between the replacement and the solution set. You should know which numbers go where. You guys good on that? Okay. Look at example 1. This is how I want you to do these problems. You don't have to do the chart. You don't have to always do the chart. That's there, again, to make it organized so you can see every step. But this is actually what I want you to do. So example 1. Let's do this actually mentally. So what I need you to do is you're not going to look at the book anymore because the answers are right there. You can just look at them. What I want you to do is just write what I write on the board, and then we'll go through it together. You don't have to close your book, or at least put something in there so you don't lose your place. Y plus 5. Y plus 5 is less than or equal to 7. All right. What do we call this according to this lesson? We call it an open sentence. Okay? And specifically, Hayes, it is an inequality. Okay? It's an inequality which we classify as open sentences. Good? All right. Why is it an open sentence, though? Just because we said so. It's in this lesson. What?
Oh, because
Has to have.
open for a couple numbers to fit in. I don't know. Like,
Close.
Because it has Wait, it's an equation and wait, I don't know. It contains one or more variables.
Okay, does it have one or more variables? That's the one check. Is it an equation or inequality? So it fits both of those. You guys got it? This is an open sentence. All right. The replacement set. Ooh, look at that. The replacement set is going to be 0, 1, 2, 3, 4. 0, 1.
Do you need to write out replacement set and then
You don't have to. In fact, the way it works is they write in the problem a replacement set, and then you just have to put in the numbers in. So like, this is what they give you in the problem. I'm going to show you what to do for the problem. Like, okay, now what work do we do? Okay, if this is a replacement set, I have to test all these numbers, and you'll find a pattern, but I test all these numbers into this original inequality. So let's do it mentally out loud together. 0 for here. 0 plus 5 is 5. And 5, is it less than or equal to 7?
Yeah.
Okay, so is 0 a part of the solution set?
Yes.
Yes, so it's part of it. All right, 1. 1 plus 5?
6.
6 is less than or equal to 7?
Yes.
1 is a part of the solution set. 2. 2 plus 5?
7.
Ooh, is 7 less than or equal to 7?
Yes.
Yes, it is equal to. 3? No. 4? Oh, smart boy. I almost had it. All right. So we say that the solution set is 0, 1, 2. Right? 0, 1, 2.
Right.
All right. Let's see. James, what's my replacement set in this problem? Replacement.
0, 1, 2, 3, 4.
What's my solution set, Lizzie?
0, 1, 2.
What's my replacement set? Kyra.
0, 1, 2, 3, 4.
What's my replacement set? Harper. Benson, solution set.
0, 1, 2.
Kendall, solution set.
0, 1, 2.
Look at that. All of you got it right. And if I called on everyone would get it right? Is that true? Really? Beth, replacement set. I see you back there. Katie. Solution set. Replacement set. Solution set. Solution set. Solution set. Replacement. She's good, guys. Reaction. Swivl. I hope you got that. All right, that's what you're doing for these problems. You don't have to make that chart, but you do have to evaluate all of them. And some of them you will have to do work. Like, if you don't know that 3 plus 5 is 8, then you work that out, and that's okay. You can figure it out. All right. Let's go to example 2. I'm going to ask you a tricky question, so be ready for it. Example number 2. Go ahead and just write. You can open your books again. Just go ahead and write where it says solve, write the whole thing. And then once you guys are done, I'm going to ask you a question. And let's see if you're paying attention. Okay. Josh, is that an open sentence?
No.
Does anyone disagree? Okay, I'm saying, is that an open sentence? What's going to make this an open sentence then? I thought this is what the whole lesson's about. Riley? Equals D. Okay, yeah, that's added that little part there. Why is it an open sentence now and it wasn't before? Benton? Oh, yeah. It has to be a mathematical statement, so equation or inequality, and it has to have one or more variables. Statement, open statement in this case. Before, not an open statement. Okay, remember how we had a solution set of one number? The first example we went through, like the pre-example. And then the second solution set was 3 numbers. How many numbers can you have in a solution set, possibly? Yep.
You can have however many the problem allows.
Okay.
I guess.
Some of them, infinite. In this lesson, finite. You're going to have 0 to 10. You're not going to have more than that. Eli, did you want to say something? 0 to 5, yeah. It's not. They're not going to be. There aren't going to be many answers. Now, some open sentences have one solution, only one. This is one of them. Okay, this is a review of order of operations. What would I have to do first? Okay, yes, Katie? Okay, what's this then? 8, so I have 5 times 8. And that's going to give me my 40, right? All right, what else would I do? Lizzie, what would I do?
You would,
So I did the top, it's 40.
you would multiply 500 and you do 500 and then 1,000.
Oh, and then you go to the bottom and you get 6 plus 2. And that gives you 8. And what do you do with those two numbers? Divide them. What do we get? 5. Now listen to me carefully. There's a reason I like this example for this lesson and for the last lesson with the order of operations. What symbols of inclusion are in this problem right here? What symbols of inclusion? First of all, everyone say they are the... Everyone sees the parentheses. And, Eli, that fraction bar right here. So you see how we evaluated this first? So we got 40. Then we go to this next and we get 8. And then the last step is to do what? Divide. You divide 40 by 8. Okay, and 5. All right, is that my answer? They want the solution set. So is that my answer? Just put 5. I want a solution set. Anyone want to come up here, Ben? You have the power now. Swivl is now recording you.
Do I need to do that?
No. So stay with him. Stay.
Set this set that you
Oh, and a circle. Yes, sir.
What was
Yeah, it's because he's destroying the image because of the lens, so I have to tilt him. Sorry, Swivl. He didn't mean it in a bad way. Okay. The end. Stop recording, Swivl.